Our scientific knowledge about Mars, especially in terms of its geological history, climate, and potential for harboring life, has expanded tremendously over recent decades. The landing site of Perseverance, the Jezero crater, was strategically selected by scientists because it is believed to have once been a vast lake more than 3.2 billion years ago. This makes it a prime location for uncovering clues about Mars' past, especially any evidence suggesting the planet once supported microbial life. Equipped with advanced cameras and a suite of sophisticated scientific instruments, Perseverance has been gathering invaluable data from its surroundings. These images and readings are more than just visually stunning. They hold the keys to unlocking Mars' secrets, helping scientists study the planet's past habitability and assess its potential for future human exploration. NASA's significant investment in Mars exploration, amounting to billions of dollars, is fueled by the age-old quest to answer one of the most profound questions of our existence. Are we alone in the universe? This pursuit has driven NASA to send increasingly advanced robotic explorers to Mars. The twin rovers Spirit and Opportunity, launched in 2003, were among the first to uncover concrete evidence that water once flowed across the Martian surface. Their findings confirmed that Mars may have once had environmental conditions conducive to life. Spirit and Opportunity were instrumental in shaping our modern understanding of the planet, especially through their detection of mineral formations typically created in the presence of water. Opportunity's mission, which lasted nearly 15 years, exceeded expectations and brought back thousands of images and scientific data that continue to influence planetary science today. In 2012, the Curiosity rover made its historic landing in Gale Crater as part of NASA's Mars Science Laboratory mission. The crater was chosen because of its geological richness and clear indicators of past water activity. Gale Crater's central feature, Mount Sharp, towers 5.5 kilometers above the crater floor and provides scientists with layered rock formations that act as a historical archive of Mars' environmental conditions. Curiosity's primary objective was to determine whether Mars ever had the right ingredients to support microbial life. The rover was outfitted with an array of instruments capable of analyzing the chemical makeup of rocks, soil, and the atmosphere. One of its most impressive tools, the Chemistry and Camera Complex, ChemistryCam, used a laser to vaporize small portions of rock, allowing scientists to study the resulting plasma and identify elemental compositions. This process yielded vital information about Mars' volcanic past, water history, and atmospheric interactions. Curiosity also studied the Martian atmosphere to understand how the planet's climate has evolved over billions of years. Mars, once thought to be warm and wet, is now a cold, barren world with a thin atmosphere. Uncovering how this transformation occurred is essential for both understanding the planet's past and planning future human missions. The rover's radiation detectors provided key data on cosmic rays and solar radiation, critical for assessing the feasibility and safety of long-term human presence on the planet. One of Curiosity's most significant discoveries came in 2013 when it found compelling evidence of an ancient streambed, confirming that liquid water once flowed through Gale Crater. The detection of clay minerals further validated the idea that Mars had a wetter and possibly habitable past. Additionally, fluctuations in methane levels detected by Curiosity sparked interest in the possibility of ongoing biological or geological activity beneath the surface. While Curiosity revolutionized our understanding of Mars, Perseverance has elevated exploration to a new level. Launched in 2020, Perseverance was designed to build upon Curiosity's discoveries while focusing more directly on the search for signs of past life. One of its core missions is to collect and cache rock and soil samples for eventual return to Earth through future missions, an ambitious undertaking that will allow scientists to conduct analyses in laboratories that far surpass the capabilities of robotic instruments. On March 4, 2021, Perseverance completed its first test drive, leaving wool tracks in Jezero crater and marking the beginning of a historic mission. Since then, Perseverance has made numerous discoveries, including unusual rock formations dubbed leopard spots, which may offer insights into the planet's ancient climate. Its mission has not only expanded our scientific knowledge but also inspired millions around the world. Initiatives like NASA's Send Your Name to Mars campaign allowed over 10 million people to have their names etched onto a chip aboard the rover, symbolizing humanity's collective curiosity and passion for space exploration. The mission also honored healthcare workers during the COVID-19 pandemic with a commemorative plate mounted on the rover. A hidden coded message in its parachute reading "Dare Mighty Things" captured NASA's spirit of innovation and exploration. Perseverance has provided some of the most detailed visuals of Mars to date. One of the most iconic images, the Octavia E. Butler landing photo, captured the exact moment the rover touched down, with a plume of smoke visible from the descent stage. Other images, such as the panoramic shot from Sol 14, revealed Mars' vast and rugged landscape with stunning clarity. The rover's rear hazard avoidance camera has helped it navigate obstacles while capturing clear views of the Martian surface. An especially captivating image from Sol 213 shows the discarded parachute and back shell lying on a ridge approximately 2 kilometers north of the rover's location, providing a visual reminder of the mission's dramatic arrival. The Perseverance mission has also included the Ingenuity helicopter, which made history in April 2021 by completing the first powered, controlled flight on another planet. The flight took place at a site aptly named Wright Brothers Field. Since then, Ingenuity has exceeded expectations, performing multiple successful flights and capturing aerial video and even audio of the Martian environment. One of the most remarkable moments occurred during its 11th flight in August 2021 when the helicopter photographed Perseverance from the air, offering a unique view of the rover in action. Images taken by both Perseverance and Ingenuity have helped scientists map the Martian terrain more effectively and identify promising targets for further study. Additional stunning images, like those taken from the Van Zyl overlook, offer panoramic views of Mars' rolling hills and geological features. Aerial shots from the Mars Reconnaissance Orbiter have also provided valuable context by showing Perseverance from space. Meanwhile, reciprocal images of Perseverance and Ingenuity observing each other in action add a human-like dimension to these mechanical explorers, highlighting the synergy of NASA's dual robotic team on the Martian surface. As Perseverance and Ingenuity continue their missions, they lay the foundation for what could eventually become human exploration of Mars. The wealth of data they collect helps scientists understand the risks and requirements for sustaining life on the planet, as well as how to conduct long-term operations in such a harsh environment. Their discoveries, ranging from signs of ancient riverbeds and sedimentary layers to variations in atmospheric gases, offer tantalizing clues about the possibility of past or even present life on Mars. NASA's Mars exploration efforts represent one of humanity's greatest scientific and technological achievements. These missions have not only revealed the secrets of a neighboring world but have also brought us closer to answering the profound question of whether life exists beyond Earth. The successful landing and ongoing operations of the Perseverance rover mark a new era in planetary science and space exploration. With its advanced instruments and compelling discoveries, Perseverance is helping to reshape our understanding of the cosmos and our place within it, inviting future generations to look toward the stars with wonder, ambition, and the unyielding drive to explore. Perseverance's accomplishments build upon decades of prior missions that laid the foundation for today's sophisticated exploration. Spirit and Opportunity, the twin rovers launched in 2003, were initially expected to function for only 90 days on the Martian surface. However, they far surpassed expectations, particularly Opportunity, which operated for nearly 15 years. During that time, it covered more than 45 kilometers, sending back thousands of high-resolution images and valuable scientific data. These rovers provided direct evidence that water once flowed on Mars, a discovery that fundamentally altered our understanding of the Red Planet. Among the most notable of their findings were sedimentary rocks, hematite spheres nicknamed blueberries, and layered terrains, all suggesting that Mars once had standing water and perhaps habitable conditions. Spirit, though ultimately immobilized in soft soil, made equally important contributions, such as detecting signs of past hydrothermal activity, areas where water and heat interacted below the surface. These discoveries were crucial because hydrothermal environments on Earth are known to support diverse microbial ecosystems. Together, Spirit and Opportunity helped establish the idea that Mars had not only surface water but also the right geochemical conditions to support life at some point in its ancient history. These early missions validated the need for more advanced rovers equipped with better instruments and the capability to perform in-situ analyses. Curiosity, launched in 2011 and landing in 2012, represented a leap forward in complexity and capability. Its primary mission was to determine if Mars ever had the environmental conditions to support microbial life. Carrying a laboratory's worth of scientific tools, Curiosity analyzed rock and soil samples, detected chemical compounds, and monitored radiation levels. It found that key elements necessary for life, such as carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur, existed in the Martian soil. The rover's exploration of Mount Sharp, a layered mountain in the center of Gale Crater, revealed a rich geological history preserved in its stratified rocks. These layers recorded changing environmental conditions over time, such as variations in water presence and atmospheric chemistry. This insight allowed scientists to build a timeline of Mars' transformation from a once wet planet to the dry, desolate landscape it is today. One of Curiosity's major breakthroughs was the discovery of organic molecules in ancient rock, further evidence that Mars once held the raw ingredients for life. Additionally, the detection of seasonal methane fluctuations remains one of the most intriguing clues about possible biological or geological activity beneath the Martian surface. This is where Perseverance comes into focus, not simply as a successor, but as a mission with a bold aim of retrieving Martian samples and returning them to Earth. While Curiosity was built to analyze samples on Mars, Perseverance is the first step in a longer-term Mars sample return campaign, in partnership with the European Space Agency, ESA. This effort will allow scientists to use the full power of Earth-based laboratories to study Martian rocks at a microscopic and molecular level, potentially uncovering fossilized microbial life or other biosignatures with greater precision than any rover could achieve alone. But Perseverance is not just a scientific marvel, it also pushes the boundaries of space engineering and innovation. The inclusion of Ingenuity, the tiny helicopter that made the first powered flight on another planet, demonstrated that aerial reconnaissance is feasible even in Mars' thin atmosphere. Originally planned for 5 flights, Ingenuity has now completed many more, proving invaluable as a scout for Perseverance. It surveys terrain, identifies geological features of interest, and helps plan safe routes for the rover. This aerial capability opens the door to new mission designs for future exploration of Mars and other celestial bodies. Another groundbreaking component of Perseverance is the MOXIE, Mars Oxygen In Situ Resource Utilization Experiment, instrument. This device successfully converted carbon dioxide from Mars' atmosphere into oxygen, a monumental step toward making long-term human exploration of Mars sustainable. The ability to produce oxygen on site could not only provide breathable air for astronauts but also serve as a key component of rocket fuel for return missions. Although MOXIE is a prototype, its success lays the groundwork for scaling up this technology in the future.